Morning all. Alan and crew, thanks for having me today. Appreciate you extending the offer. Richard, thanks for that as well. It's good insights from a developer point of view. So hopefully I can elaborate a bit more on that from a consultant point of view and how we kind of define smart buildings and why we do it, etc. So first of all, just a little bit about me and the company I work for. I work for Norman Disney Young, NDY. We were founded in Australia in 1959, M&E consultancy primarily. We've other divisions now, such as fire engineering, and the division I work in is digital side of the business, AV, smart, ICT, security. I have a strong focus on smart buildings. Our global team on smart is 40 people, so get good insights from around the world with what people are doing, etc. So what we do, I suppose, is just put a quote there. What if a building could learn, adapt, and interact with its occupants? So a smart building is about applying technology to optimize the way spaces work. So how we go about defining smart buildings with clients. So we initially come into our clients and bring them along on a journey from, they don't know what they want at the start. So we try and sit down with them and get them tuned into what they actually require. So we wouldn't lead with technology. We go in first and we look at what their outcomes are and work backwards. So it's kind of backward engineering per se. So the three kind of buckets we design to is user experience. So how the users of the building, who they are, how they'll use the building, and what kind of feel you want to give them, whether you want the hotel vibe or what type of thing, how they want to work, I suppose, make them feel comfortable in their work environment. Sustainability, I probably don't need to elaborate much on that. We all know net zero, ESG goals, etc. So absolutely one of the main reasons why we add smart to buildings, can enhance what's currently there. And operation effectiveness, how we use how our buildings work, FM side of the house, all our different systems, how we optimize them. So just some industry facts and insights I pulled from different sources. I haven't quite referenced them, but they're all from different, I suppose, different industry studies. So in the user experience kind of bracket, so they say healthier environments equals to 28% lower absenteeism. And so obviously, the healthier environment, your indoor air quality, likes of that. The studies have found that lower absenteeism within the office space. Quality workplaces show increase in job satisfaction by 20%. Again, I suppose if you're working in an environment you're comfortable in, you want to be there, you're happy to work, and it's where you want to be. And buildings with correct levels of daylight can see a 15% decrease in absenteeism, so that you've got your different daylight harvesting systems with your lighting control, the likes of that. So again, it's all about comfort, making you feel, like you want to work in these spaces. On sustainability, BMS systems manage 40% of a building's total energy consumption. That's a massive part, obviously, and it's something that we would focus on massively in smart buildings, how we can enhance that and pull a bit more from it. Fault detection and diagnostics can save 15 to 25% in HVAC energy consumption alone. So that's a kind of software we'd overlay over your BMS system, and it would read and write back to your BMS. So we use different clashes and comparisons to enhance that. And sustainable features can enhance a property's value. Richard kind of already spoke about that. So and lastly, operational IoT enabled waste solutions can reduce cleaning costs by 12%. So you can have dynamic cleaning, such as cleaners for bathrooms might have a tablet. They go around the different buildings and they can determine then when they actually need to clean. So rather than on a timed rota, they do it more dynamically. So they know the toilet's been used X amount of times. We must now go and clean. Technology can unlock 29% improvement in space management. Again, space is at a premium. You pay a lot for space, so you need to make sure you're using your space efficiently and the way you want to use it. Again, fault detection diagnostics can reduce maintenance expenditure by 5 to 15%. So again, you're more kind of proactive maintenance based on your fault detection rather than reactive. And there's just two insights I just want to focus a bit more on, and it might resonate more with people here. Just on this is a Schneider study. So 20 to 45% of energy is wasted by HVAC. 30 to 40% of workspace is not utilized correctly, I suppose. And 20 to 40% of unscheduled of maintenance is unscheduled. So it's reactive maintenance, and that ultimately leads to cost and labor, etc. So it's unplanned. If a lot of stuff happened in one day, you might be under resourced to actually manage that. So with smart solutions, you can preempt that and hopefully get ahead of it. Lastly, this is a JLL study it's called the rule of trees. It's quite known well in the industry. So it's what your typical annual spend is on within your, say, an office commercial space. Utilities cost typically €3 a square foot. Buildings €30 a square foot, but your people are €300 a square foot. So I think from that you can see that there's real good value in looking after your people, getting your people efficient, working efficiently in their spaces. So that's one of the key areas we really look at. And you'll probably know there's a number of companies, particularly one of the big global tech companies in Docklands, that they've always focused on their employees and try to get the most out of their employees. So that's where they see value. So the process in this, I suppose, from smart building, how we get from kind of concept to implemented and functioning. So we hit the design phase first. So typically we'd sit in with clients, we do a number of workshops, user experience focused, operational and sustainability focused. From that, we'd put together a technology master plan with sample costs. We feed into the costs of the project, and we'd kind of work out what we want to implement. And we'd input to other design packages, because naturally enough that their systems will all end up on smart building platforms. So we got to make sure they play nicely. We develop smart building and MSI specs. So any contractor that will be onboarded to the project, they'll have a set of rules that we want them to play with. And then we go out to tender for an MSI. So Tomas will talk more about what the MSI does. They're Master Systems Integrator. Tomas and his HereWorks team are a Master Systems Integrator. So they ultimately pull all the systems into one location and do all the funky stuff with it, let's say. So you can explain more about that, Tomas, when you stand up here. In the construction phase, so key points here are early engagement with the whole construction team. Again, Tomas's team would probably be in at this stage doing this bit. Implementation of a naming schema, so everything can talk to each other in the same language. You don't want one speaking English, they're speaking Chinese. They all got to be able to talk and have a common naming mechanism. Correct selection of hardware, very important. We must make sure the right systems are chosen, they're cyber compliant, the likes of that. And integration of systems then happens, and ultimately validation. So that's the end of your construction phase. Then into building and use. So we look at training the FM team, refining your dashboards, your reports. Then the building goes into learning phase. So it's got to learn, all the data that's coming on board. You learn different seasons of the year, there'll be different things happening within your building. So we call that the learning phase. From that, we do building tuning. So, you've learned now, you're going to tune, you're going to try and get a bit more from your building, and then onto continuous improvement. So again, you're going to go back in a loop there, back to your learning phase, tuning, continuous improvement, so on and so forth. So massive efficiencies can happen the first 2 or 3 years, then it kind of levels out a little bit. But again, technology progresses, new ideas come to light, and you can push on with it. Some benefits of this, Richard kind of alluded to some of this. User experience wise, improve comfort and productivity to optimize your work environment, enhance connectivity, everything can work correctly in your building. So rather than having them all doing their own thing, they're on this one network. Push the data to the cloud, and overlay that with different applications. So kind of application layer in the cloud, be it a single pane of glass where all your systems would sit and you can view your systems, your former analytics, your fault detection up there, read and write back to your building. And you can also have mobile applications for the users of that building. So smart building we see as a fully connected building rather than your siloed systems. One thing I want to just touch on is IT requirements. Obviously, with all this connectivity, there are certain requirements and stuff we would typically look at are make sure your systems are cyber secure. You adhere to corporate cyber compliance and cyber policies. Massively important that your systems have that in place. We have converged networks in play, as I kind of alluded to a couple of minutes ago. IoT sensor integration, whether they're on their own little, they could be on a LoRaWAN network, or they could actually sit in the building network, or they could be on 5G. They could be a number of different ways to implement them. Your data management. So again, your data, where you're going to manage data, is a GDPR compliant, etc. So is your data managed locally on-prem? It could be in the cloud. You might have your own data lake. It could be stored on multiple different systems, and you converge them all together. So a number of things to consider there. Lastly, remote access to your systems, or are you going to have a cloud hosted? So a number of different things our clients must think about there before they implement any smart systems. Next couple of things is going to skim through pretty quick because I think Tomas is going to speak a bit more about these. So I suppose, what does it look like? You might have a smart building platform here. We call it single pane of glass. All your different systems would sit together. We can put your building analytics together. You can clash your dashboards. So different users might have different requirements. You could be a manager. You might need see certain dashboards. You could be FM. You might want to see something else. Sustainability will want to see something else. You could have your whole portfolio sitting on this. So it's a really convenient way of looking at your systems, exporting data, and I suppose ensuring that you're aligned to your company's requirements there. You may have a user experience app. This would be for the occupants of the building. They can order their coffees, they can book rooms, they can do multiple different things. Their access control card, etc., might be on this. So I think Tomas again might speak a bit more in detail about the likes of this. Technologies that may be in play, just to give you a feel for it. I won't go through them all. You can kind of see on screen there. You have your typical ones like your BMS, your CCTV, like that, and then you might have air quality, your analytical platform. So basically any system within the building can be pushed. It's just a matter of deciding what suits best. So I suppose what's next in smart buildings, and some of this is next, some of it's kind of now. We design buildings that may not come to life for 2 or 3 years time. So we're designing buildings currently for probably 28, 29. So we got to think ahead. We don't want to get left behind. So what we're looking at is drone deliveries. I recently pitched this to a client in London. I thought it was crazy, but I had to explain in Dublin, we actually have Mana drones at the moment delivering food. They were talking about Deliveroo drivers and Just Eat, and basically they're pulling up and they're queuing outside the building, and it's just really messy. So I said, well, this is happening in Dublin, and they just thought it was absolutely crazy. I said, look, I had to show them in the end, but this is reality. This is what's happening. It's coming. So do you put a landing pad instead of a door for someone to deliver food? I don't know, but it's something to consider.
Yeah.
Cloud-based BMS systems. Yeah, they're ready in play. Not massively utilized yet, but I think people are just building a bit of confidence in them. So you've got controllers on-prem, but your head-end stuff in the cloud. Makes a lot of sense for a lot of people. Mobile access credentials. This is becoming really common now. We've got your Apple Watch, your phone, you're basically a digital card to get access. Easy to implement, easy to revoke. You're not pushing bits of plastic out there. People forget their access card. People don't forget their phones. So it makes a lot of sense as well. Very easily implemented. One last one, I suppose, is mixed reality changing, or mixed reality training. So VR headsets, kind of data centers, they're looking at that at the moment, like that, where you put a headset on, you've got your lineup of your electrical equipment, rather than going pressing buttons and stuff. You've got your VR headset. You can play around with it without causing any damage to the facility. So something else to consider. I was here about 3 years ago for a talk from a guy called Mark Gallagher from Formula One. He was involved with the Jaguar Red Bull team, and he was kind of just talking about how small changes can make a big impact, and particularly applies to Formula One. But I was thinking about it. I got invited to this hotel. I kind of remembered I was here for that talk. So I said, I'll try and put a bit of an analogy together with smart buildings of Formula One. So bear with me. So Formula One, continuous improvement is massive there. So Formula One teams, they fine tune every component for optimal performance. We do very similar with our smart buildings. We optimize systems for energy efficiency and comfort. So again, we're looking all for that little bit extra every time. Secondly, data-driven decisions. So real-time data guides Formula One strategy, driver strategies in Formula One. Sensor analytics can adjust building operations in real time. So we're obviously tweaking that as we go. We've got tools. We've got, people can look at that as well to determine how they can make decisions with the data from their buildings. And lastly, integration of technologies. So Formula One success stems from seamless collaboration amongst teams and the sensors that they pull data from. So teams such as strategists, likes of drivers giving data back, race engineers, like that, they all feed into the success of a Formula One team. So with a smart building, we'd integrate various technologies and systems from a central platform to ensure success of a smart building. So on that note, thank you all for taking the time to come here today. Appreciate it.